Imagine you're standing on a planet rotating around its own axis at hundreds of meters every second. You are traveling around the sun at incredible speed. The sun itself is racing through the Milky Way galaxy, carrying you with it, and our galaxy is moving through the vast structure of the universe. You are not standing still. You are flying through space, yet you feel nothing. Why? Because motion is not something you feel. What you feel is change. When I developed my theory of relativity, one of the greatest lessons I discovered was that the universe is not as simple as human intuition suggests. Reality is much deeper than what our senses tell us. And today, I want to explore a question that seems simple, but reveals one of the greatest mysteries of existence. Why does everything in the universe spin? The Earth spins, the Moon spins, the Sun spins. Every planet, every star, and almost every galaxy carries some form of rotation. Even the most mysterious objects in the cosmos, black holes, spin so violently that they drag the fabric of space and time around themselves. And if we travel to the smallest scales, deep inside atoms, we discover another strange property called quantum spin. From the smallest particles to the largest galaxies, the universe seems to have one ancient habit. It turns. But why? Why did nature choose movement instead of perfect stillness? Why is rotation everywhere we look? The answer begins with a principle that I consider one of the hidden memories of the universe, a principle that tells us something remarkable. The universe remembers its motion. That principle is called angular momentum. Angular momentum is not just a mathematical idea. It is the reason planets continue orbiting stars, the reason stars are born spinning, and the reason galaxies maintain their enormous cosmic dances for billions of years. Once something begins rotating, stopping it requires a reason. The universe does not naturally prefer rest. The universe prefers motion. But to understand why everything spins, we must travel back through time. Not thousands of years, not millions, billions of years. Back to a moment before stars existed, before planets existed, before Earth had oceans, mountains, or life. Back to the birth of the universe itself. Because hidden inside the first moments after the Big Bang was the origin of every rotation we see today. But before we reach that beginning, we must first understand what rotation truly means. Because when you say something is spinning, you imagine a ball turning around an invisible stick, a spinning wheel, a rotating planet, a dancer turning on ice. But the universe does not always spin in such simple ways. A galaxy is not a solid object. A star is not a perfect sphere made of metal. A black hole is not even a physical surface, yet they all rotate. So what exactly is happening? The secret is angular momentum. Think about an ice skater standing on a frozen rink. At first, the skater stretches both arms outward and begins spinning slowly. Then something amazing happens. The skater pulls their arms close to their body. Without receiving any extra push, without adding any new energy, they suddenly spin faster. Why? Because the distance from the center becomes smaller. The universe has a rule. When a rotating object becomes smaller, its rotation speeds up. When it becomes larger, its rotation slows down. The total angular momentum remains conserved. The motion changes its form, but it does not disappear. This simple idea explains some of the most spectacular events in the cosmos. A giant cloud of gas and dust floating through space may appear peaceful and motionless. But inside that cloud exists a tiny amount of rotation, almost nothing, a small cosmic imbalance. Then gravity begins pulling the cloud inward. The cloud becomes smaller. And just like the ice skater pulling in their arms, the rotation begins accelerating. A slow cosmic movement becomes a powerful spin. The cloud flattens into a disk. The center becomes hotter and denser. Eventually, the pressure becomes so extreme that nuclear fusion begins. A star is born. But that newborn star is already carrying the memory of the cloud that created it. It spins because its birthplace was spinning. Its planets will spin because the disk around it was spinning. Their moons will spin because the same motion was passed forward. Rotation is inherited. It is a cosmic family tradition. The spin of our Earth is not random. It is a story that began before our planet existed. About 4.6 billion years ago, our solar system formed from a giant cloud of gas and dust. That cloud was not perfectly still. It had a slight rotation, a tiny cosmic movement that seemed meaningless, but gravity amplified it. The cloud collapsed, the rotation increased, and from that ancient motion, the sun was born, along with the planets, along with Earth, along with us. Every sunrise we see is connected to a rotation that began billions of years before humanity existed. But Earth is only one example. The same law operates everywhere. The sun itself rotates, but unlike Earth, the sun is not solid. It is a giant sphere of plasma. Because of this, different parts rotate at different speeds. The equator completes a rotation in roughly 25 days. Near the poles, it takes around 35 days. The sun is not a spinning ball. It is a living ocean of moving plasma, and beyond the sun lies an even greater rotation. Our entire solar system is moving around the center of the Milky Way. The sun travels through our galaxy at hundreds of thousands of kilometers per hour. Yet because the Milky Way is enormous, completing one orbit takes around 230 million years. The last time our sun was in this position in the galaxy, dinosaurs were still walking on Earth. A single journey around the galaxy is so long that humans call it a galactic year. And our sun has completed only a small number of these journeys during its entire existence. But even our galaxy is not the end of the story. The Milky Way itself rotates. Hundreds of billions of stars are moving together in a giant cosmic structure. A galaxy is like a massive wheel made of stars, gas, and dark matter. And when we look farther into space, we find the same pattern again and again. Other galaxies rotate. Galaxy clusters move. The largest structures in the universe carry traces of motion. From the smallest particles to the largest cosmic structures, rotation appears everywhere, almost as if the universe was born with a command written into its deepest laws. Keep moving, keep turning, but this creates an even bigger mystery. If everything is spinning, where did the first spin come from? Who gave the universe its first rotation? Did the Big Bang itself create the movement, or did the universe begin completely still? To answer that question, we must travel back to the earliest moments of existence itself. But to understand the first rotation of the universe, we must go back to the beginning. Not to the birth of stars, not to the formation of galaxies, but to the first moments when space itself began to exist. When I studied the universe, one of the most surprising discoveries was that space and time are not separate stages where events happen. They are part of the universe itself. The universe is not sitting inside something larger. The universe is the thing. And in its earliest moments, everything we know was compressed into an incredibly hot and dense state. There were no planets, no stars, no galaxies, only energy, particles, and the rapidly expanding fabric of space. But somewhere within that early universe, tiny differences appeared. Small variations in density, small differences in the distribution of matter. At first, these differences were almost invisible, but gravity is patient. Gravity takes tiny imperfections and amplifies them over enormous periods of time. A slightly denser region attracts a little more matter. That extra matter creates stronger gravity. Stronger gravity attracts even more matter. Slowly, over millions and billions of years, these small differences became the seeds of galaxies. But there is another question hidden inside this story. If gravity pulled everything together, why did the universe not simply collapse into one enormous object? Why did it create galaxies? Why did it create stars? Why did it create a universe filled with motion? The answer is that the early universe was not perfectly balanced. There were tiny variations, tiny movements, tiny amounts of rotation. And those small beginnings shaped everything that came after. The first galaxies were not born as perfect spinning structures. They formed from enormous clouds of gas and dark matter collapsing under gravity. As these clouds became smaller, their rotation increased. The same principle that makes a spinning skater accelerate also shaped the largest structures in existence. A collapsing cloud spins faster. A spinning cloud becomes flatter. A flattened cloud creates a disk, and inside that disk, stars are born. This is why so many galaxies have spiral shapes. Their arms are not random decorations. They are the visible result of gravity, motion, and time working together. The Milky Way is one of these cosmic spirals, a rotating city of stars. But inside the center of every large galaxy, we discover something even more extreme. A monster created from gravity itself, a black hole. At the center of our galaxy lies Sagittarius, a star, a supermassive black hole millions of times heavier than our sun. And like almost everything else in the universe, it spins. But a spinning black hole is not like a spinning planet. There is no solid surface. No material object rotating in the traditional sense. Instead, the black hole carries the rotation of the collapsed matter that created it. And according to my theory of general relativity, this rotation does something extraordinary. It twists the fabric of space and time itself. Imagine placing a heavy object on a stretched sheet. The sheet bends around the object. Now imagine the object is rotating. The surrounding structure does not simply bend, it begins to twist. This effect is called frame dragging. A rotating black hole does not only exist inside space, it changes the behavior of space around it. Near a rapidly spinning black hole, space itself is pulled into the rotation. Anything nearby must follow this twisted geometry. Even light is affected, not because light becomes heavier, not because gravity grabs it like an invisible hand, but because the path through space and time itself has changed. This was one of the most important lessons of relativity. Gravity is not simply a force pulling objects together. Gravity is the shape of space-time. And when space-time moves, the universe responds. But black holes are not the only objects where rotation becomes extreme. There are stars that spin so fast they challenge our imagination. Neutron stars. The remains of massive stars that died in spectacular explosions called supernovae. When a giant star reaches the end of its life, it loses the battle against gravity. Its core collapses. The outer layers explode into space. And what remains is an object only a few kilometers wide, but containing more mass than our entire sun. A neutron star is a cosmic laboratory where matter is compressed beyond anything possible on Earth. And because the original star was rotating, the neutron star spins dramatically faster. Some neutron stars rotate hundreds of times every second. Imagine an object heavier than the sun completing hundreds of rotations every second. The surface is moving at incredible speeds. Its magnetic fields become unbelievably powerful. And from Earth, we sometimes see these objects as pulses of light, like cosmic lighthouses. These are pulsars. Each flash is a reminder that somewhere in the darkness, a star is rotating with extraordinary precision. But perhaps the strangest kind of spin does not belong to stars. It belongs to the smallest things in existence: atoms, particles, the quantum world. When scientists studied tiny particles, they discovered a property called spin. But quantum spin is not exactly like a tiny ball physically rotating. A particle is not literally a miniature planet spinning in space. Quantum spin is a fundamental property of nature, a built-in characteristic that particles possess. And this revealed something profound. Rotation is not only a behavior of large objects, it is also written into the foundation of reality itself. The universe seems to carry motion from the smallest scales to the largest, from particles to planets, to stars, to galaxies. The same idea appears again and again. The universe preserves motion. But there is one final mystery. If rotation is everywhere, Why does the universe itself appear to have a preferred direction of time? Why do we remember the past but not the future? Why does everything seem to move from order toward disorder? And what does rotation have to do with the arrow of time? This question leads us into one of the deepest connections in physics, because the same universe that created spinning galaxies also created the flow of time itself. And perhaps the answer lies in something even more surprising: the relationship between motion, energy, and the birth of the universe. But the deeper we look into the universe, the more we discover that rotation is not just about movement. It is connected to one of the greatest mysteries of existence. Why is there something rather than nothing? Why does the universe contain matter? Why do stars, planets, and people exist at all? Because according to our best understanding of physics, the early universe should have created equal amounts of matter and antimatter. And if that had happened perfectly, everything would have disappeared. Matter and antimatter are like opposite reflections of each other. When they meet, they destroy one another and transform into energy. If the universe had created exactly equal amounts of both, every particle would have eventually collided with its opposite. The universe would have become a sea of radiation. No stars, no galaxies, no planets, no observers. But that is not what happened. Somehow, a tiny imbalance appeared. For every billion particles of antimatter, there was slightly more matter. A small difference. Almost nothing. But that small difference became everything we see. The stars, the galaxies, the Earth, you. Somewhere in the earliest moments of the universe, the laws of nature created an imperfection, and that imperfection became the foundation of existence. This reminds us of something important. The universe does not need a large difference to create something enormous. A tiny imbalance can shape billions of years of cosmic history. The same idea appears with rotation. A small initial movement can become a galaxy. A tiny amount of angular momentum can become a spinning star. A slight cosmic motion can eventually create worlds. The universe builds greatness from small beginnings. But now we face another mystery. If everything is spinning, why do objects rotate in different directions? Why does Earth rotate one way? Why do some planets spin differently? Why do galaxies have different shapes? The answer is that rotation is not controlled by a single universal direction. It depends on the conditions where an object was born. When a cloud of gas collapses, the final rotation depends on the original motion inside that cloud. A small difference in one region creates a completely different result. This is why the universe is not filled with identical objects. Every star carries a history. Every planet carries a memory. Every galaxy preserves information about the environment where it formed. Rotation is like a fingerprint left behind by cosmic evolution, and Earth itself carries such a fingerprint. Our planet rotates once every 24 hours. This rotation creates the cycle of day and night. It shapes our climate. It influences ocean currents. It controls the rhythm of life on Earth. Without this motion, our world would be completely different. The side facing the sun would experience endless daylight and extreme heat. The opposite side would remain in permanent darkness and freezing cold. The rotation of Earth is not just movement. It is a condition that allowed life to exist. Even the moon tells a story about rotation. The moon rotates on its axis, but it rotates at exactly the same speed that it orbits Earth. Because of this, the same side always faces us. For centuries, humanity could only see one face of the moon, not because the moon was not rotating, but because its rotation and orbit became synchronized. The universe is filled with these hidden relationships. Motion creates structure, gravity creates motion, and time allows these processes to continue. But there is one place where our understanding becomes extremely difficult: the beginning of the universe itself. Because when we ask where the first rotation came from, we eventually reach a limit, a moment where our current theories cannot fully explain what happened. The Big Bang was not an explosion inside space. It was the expansion of space itself. Everywhere was the beginning. Every point in the universe was once part of that extremely hot and dense early state. But what existed before? What caused the first movement? Why did the universe have the properties that allowed galaxies, stars, and life to form? These are questions that remain open. Science does not grow by pretending we have every answer. It grows because we recognize the mysteries that remain. When I developed my theories, my goal was never simply to explain what we already knew. The goal was to ask deeper questions, to look at ordinary things, and discover that the universe was hiding something extraordinary. A falling object revealed the nature of gravity. A beam of light revealed the relationship between space and time. The movement of planets revealed that the universe followed deeper rules. And rotation reveals something equally profound. The universe is not a collection of separate objects. Everything is connected through motion. The Earth spins because the solar system was born from a rotating cloud. The solar system moves because the galaxy formed from rotating matter. The galaxy exists because the early universe contained tiny differences that gravity transformed over billions of years. The motion of today is connected to the conditions of the beginning. The universe remembers. Every star, every planet, every galaxy, every particle carries traces of a story that began almost 14 billion years ago. But perhaps the most beautiful example of cosmic rotation is not found in a star or a galaxy. It is found in ourselves. The atoms that make your body were created inside ancient stars. Those stars were born from clouds of gas. Those clouds were shaped by gravity, gravity shaped by the conditions of the early universe. The movement that began billions of years ago eventually created a human being capable of asking why the universe moves. You are not separate from the cosmos. You are one of its consequences. The universe created stars. Stars created elements. Those elements created planets. And on one small planet, the universe developed the ability to look back at itself. Through human curiosity, the cosmos began studying its own origins. So when you look at a spinning galaxy in a telescope image, you are not simply seeing distant light. You are seeing a process that connects the entire history of existence. A dance that began before Earth existed, a motion carried across billions of years, a reminder that the universe is not still, it is alive with movement. But even after understanding why things spin, one mystery remains. Why does the universe have these specific laws? Why does nature preserve angular momentum? Why does space allow rotation to exist at all? And could there be a deeper connection between the rotation of the universe and the very structure of reality itself? This question leads us to the edge of modern physics, where scientists are still searching for the hidden principles that connect everything together. But the closer we look at the universe, the more we discover something unexpected. Rotation is not just a movement of objects through space. It is connected to the deepest rules that decide how reality behaves. One of the greatest discoveries in physics is that the laws of nature do not change depending on where you are. A star billions of light years away follows the same fundamental rules as a particle inside a laboratory on Earth. The same physics that controls the rotation of galaxies also controls the behavior of the smallest pieces of matter. This idea is called symmetry, and symmetry is one of the hidden languages of the universe. When I searched for the principles behind nature, I discovered that the universe is built around relationships, not around individual objects. The laws of physics are connected to the structure of space and time itself. And one of the most beautiful consequences of these connections is the conservation of angular momentum. The universe does not preserve rotation because it chooses to. It preserves rotation because the geometry of reality demands it. If the universe behaves the same way today as it did yesterday, if space has no special direction, then certain quantities must remain constant. Angular momentum is one of them. This is a profound idea. A spinning galaxy is not simply following a habit. A spinning star is not simply continuing a random motion. Their rotation is a reflection of the symmetry of the universe itself. The motion of the cosmos is written into the architecture of reality. But there is something even more surprising. The universe itself may have a rotation. For many years, scientists have asked whether the entire universe has a preferred direction. Could everything we see be part of a larger cosmic spin? If the universe rotated as a whole, that rotation would leave fingerprints. The light from distant galaxies would carry patterns. The cosmic microwave background, the ancient radiation left from the early universe, would show signs of a universal turning motion. So scientists searched. They looked across the sky. They examined the larger structures. They tested the possibility that the entire cosmos was rotating. So far, observations show that if the universe does rotate, that rotation must be incredibly small, almost impossible to detect. The universe appears remarkably uniform on the largest scales. There is no evidence that the entire cosmos is spinning like a giant wheel, but the search itself reveals something important. Science does not only study what we know, it studies what reality allows. Every unanswered question becomes a doorway, and rotation has opened many doors. One of the most mysterious is connected to dark matter. When astronomers observe galaxies rotating, something does not seem to make sense. The outer stars of galaxies are moving so fast that according to the visible matter we can see, they should escape. Imagine spinning a stone attached to a rope. If the rope is too weak, the stone flies away. In galaxies, gravity acts like the invisible rope holding stars in orbit. But the visible stars, gas, and dust do not seem heavy enough to provide enough gravity. Something else must be there. Something invisible. Something that does not produce light. Scientists call it dark matter. We cannot see dark matter directly, but we can see its influence. It shapes the rotation of galaxies. It acts like an invisible structure surrounding them. The Milky Way is not only a spiral of stars, it is embedded inside a massive cloud of unseen matter, a dark skeleton holding the galaxy together. This means that when we look at a galaxy spinning in space, we are only seeing part of the story. The visible universe is not the complete universe. Most of the mass may be hidden. And once again, rotation reveals something we cannot directly see. The movement tells us that something is there. This has happened many times in the history of science. We do not always discover things because we see them. Sometimes we discover them because something else moves in a way that should be impossible. The orbit of planets revealed gravity. The bending of light revealed space-time. The rotation of galaxies revealed dark matter. Motion is evidence. Movement is information. The universe speaks through change. And perhaps nowhere is this more powerful than in gravitational waves. When two massive objects rotate around each other, they disturb the structure of space-time. They create ripples that travel outward at the speed of light. These are gravitational waves. More than a century ago, I predicted their existence through general relativity. But for decades, they remained beyond human ability to detect. The effect was unbelievably small. When gravitational waves from distant cosmic events finally reached Earth, they stretched and compressed our planet by less than the width of a proton, an almost invisible change. Yet humans built instruments sensitive enough to measure it. And in 2015, the first direct detection of gravitational waves was announced. The signal came from two black holes spiraling together and merging. Two objects that had been dancing around each other for millions of years. Their final moments released an enormous amount of energy, not as light, but as waves in space-time itself. The universe was not only showing us where objects were, it was allowing us to hear the motion of gravity. A new sense of astronomy had begun. Before this discovery, humanity observed the universe mainly through electromagnetic radiation, visible light, radio waves, X-rays. But gravitational waves gave us another way to experience the cosmos. We could now detect events that produce almost no light at all. The collision of invisible black holes, the violent merger of neutron stars, the hidden movements of the universe. Once again, rotation became the key. Two objects moving around each other, a cosmic dance, a signal traveling across billions of years, and finally arriving on Earth. But perhaps the most beautiful lesson from all of this is that nothing in the universe exists in isolation. The spin of a particle, the rotation of a planet, the collapse of a star, the movement of a galaxy, the waves created by merging black holes, all are connected through the same fundamental laws. The universe is not a collection of separate events. It is one continuous story, a story written in motion, a story carried by gravity, a story that began billions of years ago and continues every moment. And when we study rotation, we are not simply asking why objects turn. We are asking why reality has structure. Why does the universe follow rules? Why does order emerge from chaos? Why do simple principles create complexity beyond imagination? These questions remain among the greatest challenges in physics, because every answer reveals a deeper mystery. But perhaps that is exactly why the universe is so fascinating. The goal of science is not to remove all mystery. The goal is to understand enough to discover even greater mysteries waiting beyond. And the story of rotation shows us something extraordinary. The universe is not a silent, motionless place. It is a dynamic creation where everything is connected. Every star spins because of ancient movements. Every galaxy turns because of invisible forces. Every atom carries properties written into the fabric of reality. And every person standing beneath the night sky is part of this enormous cosmic motion. You are moving with the Earth. The Earth is moving with the solar system is moving with the Milky Way is moving through a universe that has been evolving for nearly 14 billion years. You are not an observer outside the cosmos. You are a participant in its motion. The universe is turning, and you are turning with it. The next time you look at the stars, remember, those points of light are not frozen decorations in the darkness. They are worlds in motion. Galaxies in motion, a universe constantly transforming itself. The cosmos does not stand still, it dances. And after billions of years of rotation, evolution, and change, one small part of that universe became capable of asking why the dance exists at all. That may be the greatest mystery of all. Not that the universe moves, but that the universe created something capable of understanding its movement. What fascinates you more? The fact that everything in the universe spins, or that we can discover the hidden laws behind that motion? Subscribe for more documentaries exploring the deepest mysteries of space, time, and reality.